So today's objective is basically to understand why we require a design pattern in MapReduce, right? What is the use of a design pattern in MapReduce? Why we require a design pattern in MapReduce, and why MapReduce design pattern is very much important. And also we will take one of the most widely used patterns called as the blooming filter pattern. So that's the use case we are going to take on today. So we will be focusing on the bloom filter patterns. So we'll be taking a use case and understand basically how the bloom filter pattern is going to work. Fine. So this particular topic which we are going to discuss is basically going to take one of the limitations. Means there are a lot of limitations in MapReduce. So there are, like, MapReduce is not suitable for iterations, algorithms, etc. So but we are going to focus on one of the sections where MapReduce is not going to perform consistently, and how the bloom filter is going to work, and how the bloom filter is going to help the MapReduce to perform better. Okay, so that's the objective of the session today. Fine. So the objective of the session is to clearly understand what is the impact these design patterns are going to do for MapReduce, and how they are going to improve the performance if applied properly on MapReduce. Okay, so that's the primary intention of this, so that you can also get an understanding of what are the things we are currently doing without design patterns in MapReduce and also with design patterns. So that's the objective. So is the objective is clear for everybody? So what we are trying to target in today's session? Okay, thank you. Thanks for confirming the same. So basically, before even starting, so general question is why design pattern, right? So what is the need to have something called as design patterns? Why basically design patterns are most important, not only in MapReduce, generally it's not only in MapReduce, so in across all the technologies like Java, maybe a .NET, or maybe any framework across, right? Basically, when you look back into see it, design patterns are the first heavily considered in any coding, correct? So let's consider, for example, I want to reuse the code very much efficiently. I might have written some section of the code, and for one particular use case I might have written a code, and I'll get another use case. So here we have to see how smartly we can reuse the same code which is already existing, right? So that's where your basically design patterns is going to come up. So the intent of design patterns is to make the code easier to understand, and also to make the code shareable across different use cases, so that the reusability can be achieved to a greater extent. So that's what basically the target of design patterns, right? And why design patterns in MapReduce? So primarily because whenever you use a MapReduce, right? Whenever you use any MapReduce technique. So for example, I'll take a very simple way of telling you how much effectively design pattern can work in MapReduce. So let's take, I want to join between two files. Okay. Let's take, I want to join between two files. So let me take up a small notepad so that we can understand it. So let me say I want to basically join between two files. Whereas one file is basically having something around 1 million of records, and maybe another thing is going to have something around 20 billion of records, right? Okay. So if you consider this, the thing what is going to happen is not all the records is going to join. Some of the records might join, some of the records may not join. So the point what we want to do here, so when the map process happens, what basically a map process does, a map process basically takes all the records and shuffles, sorts across everything, then finally it goes to the reduce, right? In reduce, basically we will take all the records which is coming up, again grouping by key, etc., all those kind of things. So here definitely we are sure that on the max the correct records can be only 1 million, because on the left hand side we have only 1 million, whereas on the right hand side we have 20 billion of records. So how can we make this very much effective? So why can't we filter some records smartly in the mapper itself? Why can't we filter records in such a way while going to the reducer? Instead of sending all the records, we are going to send only certain amount of records. These are the things that design pattern is going to help you, right? So without design pattern, what happens? You basically take some certain amount of records and you will compare with another certain amount of records. Mapper is not effectively used. So that's what basically MapReduce does. In any MapReduce process you take, a basic thing in any MapReduce process, we just use mapper as a stream of communication. We just take something like a delimiter or take some this column and add this column. We just use mapper as something which is passing the records to the reducer in one formatted way, and reducer is basically getting overburdened. So if can we use the mapper smartly? So in this scenario, why can't I filter the records which is only matching and sending only a less amount of records to the reducer? Can I apply some filtering functionality there? Right. So this is a valid thing. Not only on this, let's take another scenario where you want to find some elements in a particular set, and the set might be having something like 1,000 records or 5,000 records, and you want to find an element. Before even finding the element, can a filter come up, can say the element which you are trying to find is available here or not? Okay, if the element is not there, then we no need to search only, right? Then why I need to search? Tell me approximately whether this element will be available or not, right? So these are some of the design patterns. If you apply these design patterns, so basically what's going to happen is that your records, etc., all those things, as I said, this is one of the smartest use case where the mapper can be used very much effectively, right? So like this we can keep speaking on lot of things, not only on this, right? So let's like this, we are going to take one of the use case today, and we are also going to see how much effectively a filter can be applied on the same, right? So that's what basically we are trying to do. Okay, so let's take a MapReduce and let's see how it's going to work with the help of MapReduce. Okay, fine. So I'll just take one question. Deepak is asking, I'm not very much aware about MapReduce. Okay, Deepak, see, this particular thing is basically to be really frank, it's targeting the problem in the MapReduce and trying to say if this design pattern has been applied on top of MapReduce, how much easily it can solve. But telling that you can also understand what is going in this session, because MapReduce is just an algorithm which is going to group the records key and value, right? We are not going to target completely on MapReduce. We are going to discuss on some generic algorithms which going to help MapReduce to perform better. Fine. So design pattern is not only targeted in MapReduce. It just tries to tell you the solution of how much it can be done. Okay. So let's when we are finding out if a data or value we are searching existing or not, then why do I need to search it again? So Umesh, the point what we are trying to say, if you have a 20 billion records, okay, and can a filter can come back and say the record you are trying to filter may exist or may not exist, right? So we are going to provide a filter in between, so which is trained already to do the searching, which is smartly trained already to do the searching. Okay, so that's what we are trying to say. We are going to take a design pattern and we are going to train the design pattern across a particular data set, so that when you go across the actual record, you will be in a position to say this is fine or this is not fine. That's the actual thing. Yes, Vibhora, that will be enough. That will be good. Fine. And people, I am getting messages like I'm not able to hear audio, so you have to check webinar from your side for that. Okay. So yes, Umesh, we can see with the example. So that's what the example we are going to see, right? We'll see the example is going to explain it better. Fine. There is nothing it is different with combiners and recorders, etc. Shekhar. This is completely on taking a design pattern which is totally outside the scope of mapper and reducer. It's going to help the mapper and reducer in a different way. The combiner and reducers are again the concept of MapReduce only. Okay, yeah. We'll sorting both the records so that filter will be efficient. Ravindra, as I said, I think we can see the example, right? I think we can see the example so that you can understand it better, how that filter records is going to happen, so that you'll get a better picture on understanding what's going to happen. Okay, fine, Ravindra. Okay, on recordings of this, yes, everybody, you will get a recordings of this. We'll do this. Okay, so we'll see everybody for all the questions, and we'll see how the answers, because after the example you can understand the answers. Okay. So now, so as I said, who should know the MR design pattern? So basically, this design pattern is heavily targeted towards a Java developer and also for the MapReduce programmer. Basically, this requires MapReduce skills. Fine. As we already aware, I think today we can say blindly that there is a lot of people is already using MapReduce. Right. So that's why this has been targeted to the next level, how to make the MapReduce smartly and efficiently. So the design patterns in MapReduce can be broadly classified into these other things: summarization pattern, filtering, data organization, meta pattern, input and join. And as you already know, this is just a webinar session. We can't go in details. In the course, we'll be going in details of every single thing. So I will take one of the pattern, the filtering pattern, and I'm going to go over the use case of the filtering pattern so that you can basically understand how much smartly and how much efficiently it is going to work. Okay, so talking about the filtering pattern, so we are going to use a filtering pattern called as Bloom filter. So we are going to basically understand how the Bloom filter is going to work and how to apply the corresponding Bloom filter on top of your MapReduce design pattern. So Bloom filter is basically a space efficient probabilistic data structure. When we say a probabilistic data structure, it means that it is not going to guarantee you that 100% result. Yes, it is also going to give some negative results, but it is very much effectively can be used against the record data sets. So how we are going to define the filter, that much smartly it's going to work. So before even understanding the Bloom filter, so let me take a particular example with an HTML file so that you can understand what the Bloom filter is going to try to do. Okay, so I'm going to basically take an example of the Bloom filter, whatever I'm showing in the diagram here. So this is basically taken from the courtesy of a website called as billmill.org. So this has been taken from that particular thing. So Bloom filters, so what it is basically trying to say is that it is going to work on a concept of hash algorithms. Okay, so what it means by the concept of hash algorithms. So let me go over the slide and come back to the example. So what basically Bloom filter says is that, so when you are going to work with the corresponding Bloom filter on the MapReduce design pattern, the process will be split into two things. One is basically three things. One is define the filter, next train the filter, then use the filter against the data set. So this is what we are going to do. So first we are going to define the filter, and next we are going to train the filter, next we are going to use the filter. So I will come to the define the filter. So first we'll understand how the filter is going to work. So let's consider if the Bloom filter is going to give a set of documents called as, or set of data called as mango, apple and grape. Fine. What it is trying to say, I can produce you three things. I can provide you three things. One is called as positive result, next is false positive, then is negative. Fine. So let's understand in depth detail of how this is going to work. So basically what the Bloom filter says is, on a first stroke, define the filter. That's what we told, right? So let's define the filter. Here the filter size is defined as 10. So you can see totally a vector of 10 elements. Fine. And each and everything is basically whatever we are watching is the index of it. So next what's going to happen is that, let's say I am going to give something called as mango, something called as apple, or something called as grape. So what it is basically going to do is that it is going to use the hash functions. You can use any number of hash functions you want. Basically it is going to use the hash functions and it is going to set the bit for it. So how it does? So let's take that HTML example what I have. So let's see here. I'm trying to say I am going to use two hash functions here. One is called as murmur and another is called as fnb. You can use any hash functions you want, right? You can use basically any hash functions you want. The idea of the hash function is basically when you enter a particular string, it will convert that string into a particular hash key or index based value. That's the intention. So let's say this Bloom filter is going to use two hash functions. One is called as f1v, one is called as murmur. So when I'm trying to enter a string called as hello, let's say I'm trying to enter a string called as hello, I'm trying to say add to Bloom filter. So what it does, basically it says for this hello, the hash keys have been generated in the index 0 and 6. Okay, so in this data set, it's remembering the hello has been populated with bits in 0 and 6. So next add another set of element called hi. So next again I'm calling something called hi. Fine. So now it says, okay, this particular person again given the bit of 0 and 30. So what are the string you are trying to enter? Those corresponding indexes will be added and highlighted in this. So you can add any number of string. Let add test. So it is going to create a hash key for that particular test, and it's going to populate the corresponding indexes. Okay, 0 and 10. So now what happens basically is that there are three set of strings called as hello, I and test. For hello, it set the corresponding index and it populated the corresponding index. Okay, and for hi it has been taken, and for test also it was been taken. So this is basically the hashing algorithms concept used by murmur and f1b. Okay, this is totally, we don't need to worry about it. That's how they have been generated. This is an example has been taken out to show you basically how it works. How it is populated, you can go in detail of understanding how murmur works, how f1b works. Okay, you can use any hash algorithms you want, but here the concept is just to tell you how the Bloom filter is going to work. How they populated the index is depending on the hash function or the hash key algorithms which you are going to use. Here the algorithms has been used in murmur and f1b. So okay, so the murmur and f1b using these two hash functions, what we have decided basically is hello, I and test has been populated in the indexes of the corresponding Bloom filter data set. So now let's go and test. I'm going to enter hello. Okay, when I'm going to say hello, Umesh Kaushik, as I said, this algorithm is just an example has been taken to populate the indexes. This is just an example to show you how the index is getting populated. The hashing function might work differently also, just to show you how the Bloom filter works here. Okay, yeah, just to understand what basically Bloom filter is trying to do in its indexes. So when they enter hello, yes, it says hello has been populated in the indexes. It says yes, it's available. When you say test, it says yes, it is available. Let's take another element called as fruit, something like this. It says no. Fine, because that has been not available in its corresponding data set. Fine. Just it's a string has been printed, Michael, there. It's just an HTML has been created to show you how it works. I have just given a string called as maybe instead of giving yes. It's just an HTML created from our side. Okay, fine, Michael. It's just an HTML string which I have given like maybe. So let's go back to this corresponding diagram. So basically the same thing what the Bloom filter base. That's, see, one thing I want to tell you all is that this is just to explain you here how the Blooming filter is going to work. Whenever you give a particular string and mentioning the corresponding hash functions, it's going to populate the indexes for this corresponding hash index for this in its data set. Okay, fine. F1v and murmur are the hashing algorithm functions, Mamta, Java hashing functions, which is basically used, okay, which is available as a library file, not a user defined functions. Fine, Mamta. Okay, so the same thing if you go back and look into this, so that's what basically is going to happen. So whenever you declare, I'm not getting for fruit, why it is resolved as no, because the fruit indexes has not been available on that Vivek. When it's trying to create the hash key for fruit, it is trying to say the corresponding bit has not been populated on that. Fine. It is trying to, the hashing concept is a concept where it will convert the corresponding string into an hash key. When it's trying to convert it to an hash key, it populates the corresponding index as part of it. For example, for the word mango, it is using two hash functions and it is telling the corresponding hash functions or highlighting the bit 1 and 0 and 2. Similarly, for Apple, the corresponding hash functions values are highlighted as in the bit 4 and 6. Similarly, for the word grape, it says the corresponding hash functions are coming in 6 and 8. Okay, so you can use any number of hash functions you want, but only one thing you have to make sure is that whatever the hash functions you are using, all the hash functions should return in the same result. Like, so hash function 1 and hash function 2 both has to say for mango we are going to populate in 0 and 2, then only it will consider. Similarly for apple, okay, it has to say to having 4 and 6. Okay, the intention of having more than one hash function is to make sure, because one hash function may be better than another hash function in algorithmic approach, right? So that we just have to make sure is that we just have to make sure whatever it's happening. Okay, fine. So when you train this corresponding data sets, okay, when you train this corresponding data set, fine. So these are the set of things I have been trained. So I have trained only with mango, apple and grape. Mango, apple and grape says for the mango the indexes are 0 and 1. For the apple the indexes are 4 and 6. I request everybody to concentrate on the example, because all of your questions will be answered when you are going to concentrate on the example. Fine, everybody? Then we can take up the questions. That will be easy actually. Is it fine for everybody? I think you will understand all of your questions are what I'm going to explain is going to answer all of your questions. That's what I'm trying to say. Okay, if you see this particular use case, you will actually all your questions will be answered automatically when the use case is what you're going to come up. Why fruit was not answered, etc. All those kind of things. Okay, so here you see what we are trying to say is that a Bloom filter is going to train only against a particular data set. There are two things here. What are the two things? One is the real data, one is the trained data. So in this particular diagram, if you clearly see, the trained data is mango, apple and grape. I am only training with these three data. Mango says that the indexes is coming in 0 and 2. Apple says the index is coming in 4 and 6. Grape says again it's coming in 6 and 8. That's not a problem. They can collide, they can overwrite. But the only one thing we have to make sure is the Bloom filter is having an entry for mango, apple and grape in its corresponding vector. So once it having its corresponding vector, so what's going to happen? We are giving in the real time use case, we are taking mango. And it says mango is available because mango has been populated in this corresponding indexes. It says yes, mango is available. It says true positive. Then we are trying to give something called as fish. Okay. Unfortunately, the trained data set have been populated only in these indexes. Fish is not available in that particular index. So it says no. So let's say I'm giving something called as banana. When you say banana is coming up in the indexes 4 and 6. While training, I not trained with banana. I trained with apple and grape. Apple also ended up in 4 and 6. Fine. So it trying to say that banana, unfortunately, banana is also having an entry in 4 and 6. So that is called false positive. It says if it's tried while decoding its corresponding index, and those index are getting populated in its corresponding hash function, so it will say yes, it is available too. So that is called as false positive. So false positive is something which is it's trying to say, even though in the trained data set this is not available, or in the corresponding use case it is not available, but this particular person is trying to fall in that particular index which it has been trained. Okay, so if you see banana is going to see everybody, Vikash and Michael, this is just an example representation what is showing here, not the actual use case, right? We're just trying to say banana is falling in the indexes which it has been trained. The actual use case only will have the actual implementation. And use case, a representation here which is trying to tell you that banana is trying to fall in that particular index which has been already trained. So even though it is not part of the data set, it is just trying to say this is also falling under the false positive. So false positive is something, there are something in the data set which may not be existing in the actual trained vector. but since it is matching with the indexes, so it is going to come up and say it is available. So that is called as false positive rate. So we have to mention what is the false positive rate from our side. You can mention whether the false positive rate may be 20% or 30%, etc. Up to you. You have to say how much false positive is acceptable. Fine. But the only biggest advantage here is if the Bloom filter says if the corresponding data is not there, it is definitely not there. So that is the biggest advantage of you fail. Okay, how banana is falling in the index. So calculating hash is overhead. So this is not an overhead performance issue and all, because this is happening in the Hadoop MapReduce algorithm. Hadoop MapReduce is actually smarter in calculating the hashing concept. So that's not a problem at all. So it's going to be definitely faster. Fine. So we are going to train across a data set, and those data sets is going to be filled in the indexes, and the given string, if it's matching in the correct index, it says fine. Okay, so fine. So that's what basically happens. So here the banana is basically not part of the actual data set. The actual data set is having only mango, apple and grape. I have trained with only mango, apple and grape, but I'm trying to give banana. Still it is trying to say banana is false positive because it is still falling in the indexes of mango, apple and grape. Okay, that's the reason, Morgan. I told only check only for mango, apple and grape, but I'm trying to give banana. It's still trying to say it is available because it is falling under the indexes of mango, apple and grape. Okay, sure. Okay, for everybody, yes, the one as I said, right, the next is the actual implementation. Once we finish the complete implementation, I have to show the actual implementation. I'm going to show the actual implementation. Find the one. Yeah, fine. So one more thing, let's see how so basically when you see this, right, when you see this particular example, if have been taken, there are only two things is going to happen. There are only two ways this Bloom filter can be represented. How the performance can be improved much better. So if you are basically going to add more hash functions, it is going to provide a very good result. Fine. But at the same time, if you add more hash functions, it's going to get a little bit slower. So there are only two things going to be possible here. Either you have to provide more hash functions. Okay. So as a Bloom filter, I am going to produce only two things. One is called as positive, one is called as false positive, one is called as negative, right? These are three things we are going to provide completely. A positive which says yes, data is available, and there is a false positive which says the data, yes, it's not there, but still we are telling up because it matches the index. It matches the index in vector. Fine. And a negative is something which is going to take care of, which is totally not there. So when you give a particular record, you are going to get all these three things. If when you get a particular data set and when you execute the actual use case, the Bloom filter will end up in these three results. It will say either in positive, it will say either in false positive, or it will say either in negative. That's the responsibility of taking Bloom filter. Okay, and the performance of this can be increased in two ways. One is either mention the hash function, more hash function, okay, or the false positive percentage. Two things are available to you. So fine. So if you mention the false positive percentage as more, so basically you are basically record which is coming up is not guaranteed is going to be existing or not existing. So with this, let's take a corresponding thing. So what if train set contains a million records and generation hash function for all those who decrease the performance? See, Devi, the trained records should not contain the million records. Train set should be always a very minimum train set. Fine. So what's what Bloom filter is trying to say? If you provide more hash functions, it's always better. So you have to take a call. Either provide more hash functions or if you don't want more hash functions, if you're okay with an 50-50 result, then produce more false positive. So only these are two options, correct? False positive is not calculated at debug. False positive is something which we have to give whether this much amount of record is acceptable or not from your side. The fine debug, it's not which we are given, we can say. Why not keep smaller table in the cache? You can't keep smaller table in the cache and all because the MapReduce is a parallel distributed algorithm. It will fail. If I use more hash functions, it will fill hash. Yes, down. That's how basically it works, right? Okay, so let's take a real use case of understanding how it's going to work. So basically what we are trying to do is that we are going to, I have basically the records in my, I have the records in my, let's take the actual data set which we are going to work on so that we can understand what we are trying to do. So basically I'm taking, we have something called distributed cache which will be available on every node. Before distributed cache cannot handle million records, it will throw out of memory exception. That's why you have a concept called as Spark and all. In MapReduce you can't accept. Fine, fine, Vibor. How will decide which data will fall under post? I will coming there, Raman. So let's take the actual example we can understand. More hash functions mean more hash functions means more accuracy. Yes, yes, yeah. So let's take an actual data set which we are going to work on. So the data set which we have here is basically is a crime data set which is basically trying to tell, which is having the ID, which is having the case number, the primary type, description, location, etc. All those kind of things. So here we are going to try, we are going to train the filter to find which are the cases are arrested against the theft case, which are not arrested against a theft case. So basically we are going to create a Bloom filter. We are going to train the Bloom filter with some amount of records, and we are going to say to the Bloom filter, find when the actual data set comes, tell me who and all has been arrested and tell me who and all has not been arrested in the crime set data set. Okay. So the first thing what we are going to do is that we are going to train the actual data set how it's going to work. Okay, fine. So let's see the particular example execution and we can go one by one. So the first thing what we are going to basically do is that we are going to take the case IDs for training. Since the record is very huge, right? So let's take the case IDs for training. Fine. So what are the case IDs I'm going to consider for training? Fine. So the case IDs what I'm going to consider for training is I'm going to take the case IDs which is containing the vehicle theft and the automobile. So basically I'm taking the case IDs which is having automobile and the corresponding vehicle theft. So those are the case IDs I'm going to take. So let me run the particular MapReduce algorithm which is going to take only the case IDs satisfying this condition. So that's the first thing I'm going to do. So against this data set, I'm going to run the MapReduce, which is going to basically take the data sets. Okay, so let me take the corresponding MapReduce code and execute the MapReduce code first. So I'm going to basically execute it and take only the case IDs, which is going to match it. Okay, so let me execute it. So first let's take some of the case IDs, which we are going to train our data set. So data set is going to plan to train on some data set with help of the Bloom filter, which is basically going to tell whether these theft cases are arrested or not arrested. Because we have an input data set which is having all the information. We can't go across the complete data set, correct? So from the complete data set, we are going to take some of the use cases IDs, which basically we are trying to train our Bloom filter data set. Okay. So let me first take the corresponding use cases ID. So we will call this as an hot list data. Hot list is something which are the case IDs we are planning to work on top of it. Okay. So let the MapReduce code finishes from the actual data set. Okay. So let's go and see the hot list data in my HDF first. So let me take, so from the actual data set, which is having a complete information of the case information, what's the location, whether the theft has been arrested or not, etc. I am basically going and seeing the hot list which has been generated. So we have taken only some of the use cases IDs as we discussed, the use cases IDs which we have taken only having the automobile, and we are going to train their use case IDs with the Bloom filter now. These use case IDs I am going to train. So how I am going to train? So I am basically have a basic Java code which is going to train. Okay. The problem statement was not clear what we are trying to filter. So Abhijit, the problem statement, as I mentioned, we have a use case called as crime case document, which is having a huge number of records of all the crime cases telling whether it has been arrested or not arrested against the theft. So what we are basically trying to achieve here is we are going to train the filter in such a case that when we provide some use cases IDs to that, it will say whether this case ID is arrested or not arrested. Fine, object. That's the problem statement. Fine. We have a huge set of document which exactly says which no, we are not trying to reduce the search time. We are trying to find a Bloom filter which is exactly going to tell given the use case. Okay, given a billion of records, given a million or billion of records. Let's say you have this is a file which is basically having the use case ID and is telling what is the corresponding crime use case, whether it is a theft use case, etc., whatever it is. For example, the use case is having a theft. There is a use case which is having a public peace violation. There is a use case which is having a domestic battery, etc., all those kind of things, and is telling whether the arrest has been made or not. So in this million of records, if I give some 10 use cases and I have to find whether arrest has been made or not made. So are you going to search against all these records, or are you going to have a filter, something like Bloom filter, which is smart enough to tell you immediately, yes, this is arrested or not arrested. That's the use case. So which is a better approach to do? Right? Right, Avjit? So that's what we are trying to do. Is the use case is clear? For everybody, the use case is clear? Okay, sir, this Bloom filter will give me correct answer. Yeah, thanks for confirming, everybody. Yeah, thanks for confirming. Thank you. So just we have so it's basic simple document which is having millions of records, which is telling what is the case ID, whether the case ID is arrested or not arrested. So basically I am going to have a million records. I'm going to have a million records with a case ID and with the what is the case, whether arrested or not arrested. For example, case ID 1, the case says theft, arrest has been made, means yes. Okay, case ID 2, the case ID may be public violation, arrested, no. Again, the case ID 3 is theft, arrest has been made, yes or no, yes. Like this, I have millions of records. Now, what I have to do, I'm going to all of a sudden, I'm going to take some 10 case IDs and I need to find, okay, and I need to find whether these 10 case IDs are arrested or not arrested. That's the particular use case. Fine. So what I'm basically trying to do for this particular use case, I need to train my Bloom filter. So in order to train my Bloom filter, I can't take complete million records. So what I'm trying to take, I'm just trying to take records only like which is having theft or automobile. So I am taking the use case IDs to train my filter which is having only vehicle theft or automobile. That's my use case I have taken. I can take any records I want. Out of the million records, the case can be a public violation, the case can be a theft, automobile, the case can be a murder, etc. Whatever it can be. I can't take everything. So I am taking some of the use case IDs for training in order to make sure automobile is the name of the case, Vivek, whether arrest has been made against this automobile or not. Okay, so fine, Michael. So we can take only a certain level of things. We can't take complete records to train, right? I'm just taking only some of the things which has been done. That's all. Okay. So let's see what are the total number of use case IDs I have got, which is falling under the vehicle theft or the automobile. So basically the use case IDs which is going to fall under the vehicle theft or automobile is going to come around something. Okay, so out of the million records what and all I have taken some 91,882 records and I'm going to train my filter with this 91,882 records. Right? Okay? So you can take anything you want. I have taken to train my records with vehicle theft or automobile. You can take whichever you want. So let's train it. So let's train the corresponding thing. So here comes the actual thing. So if you see in training what happens. So let's train. So this is what the actual thing is going to happen. So see this carefully. So now when you see this particular training, let it train actually. So when I'm training this particular record, so what I am trying to do here is that I am telling what is the total number of records which is available for training. Consider false positive. So I'm giving a very less false positive record. The false positive record I'm giving 20%. So what happens? It ends up it's creating more 6 hash functions, right? And so that the training has been provided with more hash functions because the false positive result has been given 20%. So I'm telling you have to exactly find 80% of the records. Train yourself with 80% of the records. So the false positive percent is exactly only 20% of the records, right? So that it resulting in more hash functions. So for example, let's consider I am giving the same use case with more false positive record. So basically what's going to happen, let's say I'm giving it, okay, points, Mamta, the API takes is at 20%, Mamta. The API internally takes at 20%. Fine. That's 2% for us. The API takes us 20%. That's how it asks actually. It goes on a scale of 1. So now let's see I am giving the false positives more. So obviously what's going to happen when I give the false positives more is basically is going to end up in less hash functions. Can you see here, right? It's taking only 5 hash functions because you don't want the accuracy of the result. You want only 60% as correct. You want 40% maybe or may not be in the kind of format. So let's say I am giving more hash function. Let's see I'm giving 0.07. 70% of the records I'm telling let it consider can enter in false positive. So when you enter this particular thing, basically you can see here again what happens. The hash functions is keep reducing. So the more the false positive records, the hash function is basically keep reducing on, right? So let's train with only 0.02%. Okay. So this is the amount of records it's basically adding. So I have trained my records. I have taken out of the huge number of records. I have taken only some amount of the records and I have trained my corresponding false positive records. Okay. And so after that, what's going to happen is that, and I'm telling the false positive record should be only 20%. So this particular person has been trained and the trained information is going to be basically written in the format of a sequence file. Okay. When you take the corresponding Bloom filter, it will be available in the part of a sequence file. Now what I'm doing on the rest part of the use case is that I'm taking, if I'm going to filter, I may miss some filter condition. I will not get accurate results. So this is like a training the data set, right? So this is basically training the data set, what's going to happen. So it's how smartly you're going to write your filter on the training condition. That's what is going to happen, right? So this is a training. You have to take the call on the data set, what the training you're going to do. So if you're going to give less hash function, if you're giving the more hash functions, it will never fail. It will guarantee it will never fail. Provide the more hash functions, it will never fail. That's what the design pattern guarantee is all about, right? Fine. So next what I'm going to do is that basically I'm going to dump all these records into Hbase. Basically I'm not going to run this operation now because it's having a huge number. It's taking a lot of time to dump the records into Hbase. Basically I'm just showing to Hbase the records what I have dumped. So Hbase shell. So basically we have taken all the records and dumped the complete records into the Hbase. So if you see the complete records, so there's a table called as crime has been created. So if I going to say scan crime, so basically it's having a huge number of records, which is basically having the location of the crime and basically what is the crime, whether it's arrested or not. All the records is available as part of the data set. All the records which has been there is dumped into Hbase. So now what are the things I have? I have all the records in Hbase. There are two things I have. I have all records in Hbase. Fine. I have a trained Bloom filter. So these are the two things I have. I have a trained Bloom filter which is expected to give 20% as false positive. Fine. So now what I am going to do, I am going to take some 10 records and I am going to see whether the record is existing in the Hbase or not. So I'm going to use the Bloom filter and I'm going to find it. And I'm going to find whether the records, I'm going to take some 10 case IDs against the Hbase and I'm going to find whether they are arrested or not arrested. Okay, because this guy has been trained with this sequence to find whether it is arrested or not arrested. So just think, without Bloom filter, what might have happened? Without Bloom filter, what might have happened? You have to go through Hbase, all the records, etc., all those kind of things, right? So with Bloom filter, what happens? Now you are guaranteed enough to end up in a very fast operation, primarily because while going to fetch against the data set. So let's see, I am just going to take, okay, it's going to keep running on. So, but Hbase has faster, whatever it is, Hbase having sorted or etc. Hbase is basically having million records now. Okay, whatever thing, without Blue filter, it will take time. MapReduce will take time. MapReduce will fail. Right? So we have a person who is very much smarter, right? Who has been trained for you to tell whether this is going to available or not. So is that is going to faster, or going against Hbase is going to be faster? Right? So that's what we have to think. That's what the main thing we are trying to understand, right? False positive, what we are trying to say is that false positive scenario where, so that's what we are trying to say. While we training, we taken some strings and we applied the hash index. So for example, mango, apple and grape, right? Those indexes are filled. Unfortunately, banana, which is not part of it, but still it is falling under the same index of mango, apple and grape. Right? So in that scenario, what happens? That is not correct, but because the index is matching, it is trying to say it is available. So that is what it is asking, how much false percentage you want. We are telling only 20% of the records like this is acceptable. Okay, so now let's see, interestingly, I am going to take some of the use cases. Let's take some 10 use cases. I am just taking randomly some 10 use cases. I am not, basically, I am, whatever the records I have in my Hbase, right? I dumped all the records into test case. So basically I am going to take some random use case, and I just taken the corresponding use case ID also. I just take that and I'll show you actually. So this is basically I have just taken some random use case IDs. Okay. I'll show you Sham after the execution. I'll show you. So let's please concentrate on the your use case. Fine, Sham. I can go with, but let's understand the use case. It says fine, Sham. Why to keep in Hbase if you are using Bloom filter? Avjit, what we are trying to do now is that we are going to take these 10 records and we are going to find it against the Hbase with help of Bloom filter. Without Bloom filter, what's going to happen? It's going to take a long time for us to find and search, etc. All those kind of things. So these are the use case IDs, and the data is available in the Hbase. Without Bloom filter, I have to take one record and I have to find completely against the Hbase and see what is the status of that record. Now these 10 records I have been taken. Okay, and what I am going to use, I am going to search against the Hbase with the help of the trained Bloom filter. Okay, find object, that's what we are trying to do. Do we hardcode the IDs for Bloom filter? So Vinay, so what we are trying to do against the use cases. So the use case is something, what it is trying to say is that I have some million records in Hbase. I have some million records in Hbase. Okay, and I am going to take some 10 use case IDs and I am going to find against the Hbase. So it is going to take a lot of time. Correct? So if I'm going to train something, it is going to provide faster result for me. But the search result may not be 100% correct. Yes, Avjit, it not be 100% correct. So that's what we are trying to say, how much 100% correct you want to be. We are telling 80% correct is fine, 20% don't allow. That's fine. That's fine. We need to have but most of the scenarios we never need a exact match records. How can be 80% fine? Because while training I told, right? While training I clearly told what is the false positive percentage. You can see here, right? While training I told allow 20% of the record only to be false positive. So what happens basically in this particular example, so we'll take from I just recap before going for the final step. I had a very huge number of records. In that huge number of records, basically I have taken only some amount of records. I have trained my filter. Now all the records is available in my Hbase, and I am taking only 10 use case ID to search whether these records are available or not. So fine, and it's totally up to you to decide whether 20%, you can give 0% also. It's up to you to decide how much false positive result you want. Either it's up to you. If you want absolutely zero false positive result, then you have to go for more and more hash functions. then it might end up in slower performance because hash functions will take some amount of time. Okay, so I'm just going to execute the final execution of it. So with me, I have two set of things. All the records in the Hbase is available, and I also have the train Bloom filter. So the final section, which I'm going to take the use case IDs, some random use case IDs. Okay, what are the random use case IDs available? For these use case IDs, I'm going to use the Bloom filter, and I'm going to find whether these guys are arrested or not arrested. Okay, that's what the final thing I'm going to execute. So while executing, what I'm taking, I'm going to basically take the IDs. I'm going to basically take the IDs. Okay, I'm going to take basically the IDs and the corresponding Bloom filter name. Okay, this is the Bloom filter which has been trained, and this is where all the IDs are available. And I'm trying to say, please paste the final output in the corresponding location called as Bloom underscore final filter. So let's see what it does. Okay, so I have a trained person who is basically have the knowledge of how to work with this data set, and I am giving basically some 10 use case IDs, and we have millions of records in the Hbase, and basically it falls under this particular category. So let's see what's going to happen now on the execution of this output. See, it's completed. It's completed. In fact, it's completed very fast. Okay. I don't think so. Without filter logic, it cannot be completed this much faster. Whatever you write, right? It cannot be completed this much faster. So it goes back here, and let's see the final filter output. Let's take the final filter output. So it says exactly out of the 10 use case IDs you have given. Okay. So on the automobile and the vehicle theft, you can see these are the guys has been arrested, and these are the guys has been not arrested, right? So that's what basic use case of applying a design pattern algorithm. Okay, fine. Yeah, so basically Bloom filter helps in faster analytics of data compared to other things. Fine. So if you look at the complete code, all the PDF and the video etc will be shared to you all. You can also go and look at the complete code whenever you want. In the span of 24 hours of time, all this code which has been used etc will be available to you, right? So if you see the query Bloom filtering, basically this is where the Bloom filtering logic comes up. So basically what it does is that it basically takes the data from the Hbase one by one, and it is trying to read the database, and it is basically you can just go over the code by yourself. Everything is written by you, and we are telling what is the corresponding MapReduce we have to apply. Okay, so you can see here this is basically used very widely. So we have very efficiently searched an element across the Hbase with a 80% accuracy of the result, and this is very widely used use case records. Okay, the more you are going to train the filter, it's going to perform better. So you cannot always perform search against billions of records. You cannot do search against 80 billion records or 2 billion records or 5 billion records. Okay, how did you train the data set? The training of the data set happened. No, I just execute the command I showed you. No, right? There's a training data set called Bloom filter generator. It basically just takes the data set, it creates the hash index, and it applies on top of it. Fine. So for all the remaining pattern details, understanding the training of data set, you can see BF generator, which is using the murmur hash algorithm to train it. Fine. So for all the remaining pattern details, etc., you can join this particular course. Right? You can join the particular course of the Edureka, where we'll provide more and more discussion on this. Okay, so as I said, this is providing, you can ask me how much accuracy etc, it totally depends on how much efficiently you are going to train. You can provide more hash algorithm concepts too, right? You can always have more and more hash algorithm concepts, right? You can always join. Just to show an example of how much efficient, without let's you put it after applying the Bloom filter, you can always understand, right? Please show me the final output. Yes, Prashant, I showed the final output, right? This is the final output. We have taken some 10 use case ID. Okay, we can take in some 10 use case ID, and we can we have seen whether they are updated or not, right? Yeah. So probably Prashant, as I said to others also, right, the particular use case output which you are seeing here can be done better by selecting your own hash algorithms. Okay, so how to level murmur hash, all these things will be part of the code course theory. Okay, I will write the Bloom filter code. The Bloom filter code will be given to you, everybody. Ankit and everybody about the code and algorithm, etc. will be given, will be shared to you in next 24 hours of time. Whatever I have been written here. Okay. will be shared to you in next 24 hours of time. You can understand the Bloom filter code. So there is no corresponding. See, if you know the MapReduce logic, it will be better to start the course. But I don't think that's a major constraint. Always you can, in the part of the course, they will be always explaining you how the MapReduce is basically going to work. Then only they will go and explain the rest of the things, right? But Java is quite mandatory. Again, they can provide you links whatever for the Java, etc. All those kind of things. As I said, if you are going to contact the support on the same, they will explain you better on the same thing, right? So this is a code of a particular hash logic function which is available here. You can look back into this also. Would this MR design pattern also course? Yes, these are all part of the course. The course explains all the design patterns, everybody. Bashwaraj, we will give you the code, Bashwaraj. You can find the corresponding hash logic in that. Fine, Bashwaraj? Yeah. So basically, if you see here, right, this is just an understanding of you to show how much you yourself just think and understand. Without this Bloom filter, if I upload over Hbase, it's going to take quite a lot amount of time, right? So the course is starting very much immediately, everybody. Okay. Is it similar to machine learning training? No, that is different, Umesh. So this can be applied on top of all a current MapReduce codes itself. Fine, Umesh. In different language, basically, Ravikant, we won't do because Java runs, MapReduce algorithm runs on top of only on Java. Yes, Krishna, you can do one Hive and etc. all the other things. Okay. No, Umesh, the only one thing, this is not working the same way of how machine learning works. So please understand that. That's what I'm trying to say. This is different. This is to work along with the MapReduce code. Fine, Umesh? Yeah, that's what point I'm saying. Bloom filter can be applied anywhere, so it's not particularly on this thing, but you can use it MapReduce algorithms. Yes, Funny. Once you join the course, we'll be suggesting the book details, etc. No, Ravikant, what I'm trying to say, Bloom filter is just a concept you can apply anywhere. It is very much effective used with the MapReduce. Right? That's what. Basic knowledge is enough. The basic knowledge is enough. All the course details and everything, I request you to all immediately contact the support. The support will give you all the code has been used so that you can go through the code and also you can find it. We'll produce you nice examples and etc. All those other part of things. Okay. Fine, everybody. All the course details, everything you can contact the basically you can contact the support immediately where the support will answer all the questions, and also you can join the part of the course. We'll produce the nice course content. We'll go through all the things, how you can effectively use your current MapReduce very much effectively, etc. All those kind of things, and anything regarding your certification also will be added as part of the course. Okay. Fine, everybody. So from my side, yes, Shubhajit, tell me, Shubhajit, what is the question, Shubhajit? Reference material, as I said, Subhajit, we are going to provide you all these things in the next 24 hours of time. Okay. Yes, Ravindra, we're done with the webinar. Can design patterns be applied to improve performance? Yes, Kunal, you can also approve on Spark also. Yeah. Okay. Fine. So thanks all. Thank you very much for Green Elephant. I can say what are those? Oh, that is Evernote, Michael. That's an app called as Evernote. You can use on this. Evernote is an app. Okay, so thanks for the session. I hope you understood what is it's an app to maintain all your notes, everything. Okay. I hope if I have not answered most of your questions, I apologize on the same. So please, you can contact your support on the same. I have only one request finally is please kindly fill the feedback at the end of the session. It really makes a lot of difference when you fill the feedback at the end of the session. And please fill the feedback. And also I hope you get a better understanding of basically what design pattern does. Okay, and thanks a lot everybody. So please contact the support on the same thing for the course details and kindly fill the feedback at the end of the session. Thank you all. Thank you very much. Please kindly fill the feedback. Thank you very much for your patience, and I apologize if I not answered most of it. And please fill the feedback. Thank you all. Thank you everybody.